Hello everybody, welcome back to the channel. Today we're going to be diving into one of the most important concepts in computer science, the von Neumann architecture. The design is the foundation of most modern computers and understanding it is crucial for exams and real-world applications. So let's break it down. Before we do, please drop a like, subscribe and comment any questions or suggestions. We're hopefully going to be running some live streams in exam periods, so always keep an eye out for that. And go and check out the rest of our videos. We've got loads of past paper videos, loads of content videos for you to check out for maths, computer science, and eventually all the other STEM subjects. So, the von Neumann architecture. This is a picture of John von Neumann. He was a computer scientist and he created this architecture, which was a very, very, very revolutionary development in computing. And you don't need to know for the qualifications too much about the history of the von Neumann architecture. So, what is the principles of the von Neumann architecture? Well, data and instructions are stored together in memory. In the conflicting architecture, which is the Harvard architecture, there's two separate memories, one for data and one for instructions, but the von Neumann architecture stores them both together in the same memory, meaning the computer doesn't need a separate storage for program code and the data it processes. Both are stored in RAM and in binary form. This allows dynamic program execution, so a program can modify itself or other data in memory during runtime. It means instructions are fetched and executed sequentially. The CPU fetches one instruction at a time from memory, decodes it and executes as covered in our fetch decode execute cycle. This is called serial execution, which keeps things organized and predictable. While modern processors use pipelines and parallelism to improve efficiency, they still rely on this fundamental model. So obviously, a lot of the modern processors we use now are hybrid versions of this model. This still is the main concept on which all modern processors are built on. And like I've said, the fetch the code execute cycle is the key functionality of this, allowing smooth programming, continuing until no instructions exist. But why is the von Neumann architecture such a big deal? Before von Neumann, computers were hardwired for specific tasks. If you wanted to switch tasks, you had to manually reconfigure them. The von Neumann architecture means a single machine can perform many different tasks, programs can be stored and updated easily, and computers became more powerful and widely accessible. And some examples of von Neumann architecture usage is in basically everything we use: PCs, laptops, gaming consoles, supercomputers, to name a few. Smartphones, everything you can think of that has a modern day processor in. I think another really important reason the von Neumann is so good, and this is something definitely to talk about, is that it's this dynamic use of memory. So whereas in the Harvard architecture you had to have a split memory, in the von Neumann, if you've got more instructions than data, it doesn't matter. You're not wasting any memory. Whereas in the Harvard architecture, you have a lot of wasted memory because you've had to split it into two. So another key component in modern processors is cache memory, a small but incredibly fast type of memory built directly into the processor. Let's see why it's important. Well, cache memory allows the CPU to access frequently used data and instructions. So it stores these frequently used data and instructions closer to the CPU, which means it's faster to access than if it was getting them from RAM. The more cache a processor has, the faster it can process tasks. However, cache memory is extremely expensive and very, very small, especially typically much, much smaller than RAM. So to balance speed and costs, computers use different levels of cache memory, but that isn't A-level content, so do not worry for GCSE. Important thing with cache: small, very fast, very expensive. That's the key things. It stores the frequently used data instructions and it's faster. Allows those instructions to be accessed really, really quickly, which speeds up the computer. That was a nice short video. Quick recap: the von Neumann architecture is the design model that most computers use, featuring a single memory for both data and instructions, the structured FDE cycle, special register to manage processing, and cache memory to speed up data access. Understanding this architecture is essential for anybody studying computer science. If you found this video helpful, don't forget to drop a like, subscribe, or comment if you have any questions. Thanks for watching, guys, and we'll see you in the next Spark Revise video.